好，那么现在呢，已经晚上8点了，那么我们就开始今天的这个直播研讨会的内容。那今天呢，我们的题目是CANopen I/O 设备配置文件，就是 CiA 401。OK，so 对，这就是今天的一个主题。So Mr. Kaplun, could you please introduce yourself shortly?
So, good evening. My name is Oskar Kaplun. I'm working for CAN Automation for about 10 years. And I'm an electrical engineer. And at CAN Automation, I'm doing a technical secretary job supporting our members with developing of specifications. Besides this, I'm also testing CANopen devices, CAN Automation. And today, together with my colleague Yao Yao, I would like to introduce you into our I/O module specification and our CANopen I/O modules, how we designed it, and what are the benefits for you if you design it in your system. Thank you.
Okay, thank you. 好，那么今天的演讲者呢，就是我们 CiA 的工程师呢Kaplun 先生，他呢已经在 CiA 工作10多年了，已经快20年了。然后呢，他也是负责若干个技术小组，包含 CANopen 的这个设备规范的若干小组，比如说这个今天的题目 I/O 设备，然后 lift， 还有这个运动控制等等，还有这个编码器。而且呢，他是测试工程师呢来进行这个CANopen一致性测试的执行者。所以说，您如果以后这个开发的设备需要进行CANopen一致性测试，然后取得这个证书的话呢，那这个产品呢是要寄到我们德国的这个测试实验室呢，由Kaplun 先生来测试。OK, next page. 我本人呢，相信您可能如果以前参加过，也都认识我。我是2016年在 CiA 任职，然后也是担任若干个小组的技术秘书。OK, thank you. Next page. 那么这个就是今天的一个内容概要首先呢，会简要介绍一下 CiA， 然后呢会介绍一下 CANopen I/O 设备的这个配置文件401。那么呢，401的这个设备和应用，并且呢，在最后呢是将401映射到这个 CANopen FD 上的一个发展。Next page. Next page. Yeah. 那 CiA 呢，您要是了解我们的话呢，也都知道我们是成立于1992年，然后呢，主要就是为了为了这个提供基于 CAN 的技术产品和市场信息，然后呢。协助呢我们的会员公司企业呢共同开发一些新的规范呐，或者是新的技术。Next page。那我们坐落在德国的纽伦堡，您看到呢就是我们的办公室，然后呢测试实验室也在这里。Next page。那么在2021年的时候呢，我们已经现在有700多家会员了。中国呢现在咱们有30家会员，也是一个每年都是在增长的趋势呢。也是说明 CANopen 其实也是虽然不是说现在最新的一个技术呢，但是用的人也是公司呢就是这CANopen 的产品其实也是在市场上是越来越多的。Next page。在这一页您看到呢，就是有几个时间点比较重要，比如说94年的时候，首次发表了301的这个CANopen的通讯协议，然后这个401的现在的这个应用的版本 CANopen 401的版本 3.1.0 呢是在2013年发表的，然后 CANopen FD 新的这个CANopen 通信协议基于 FD 的这个是在2017年发表的，然后在2019年呢。这个 I/O 的工作小组呢，开始研发将这个401呢映射到 CANopen FD 上的这个文件的一个制定。Next page。一个技术小组的简介，这张图呢，您看到这个 I/O 模块的这个小组是在这个 IG Profiles，这个小组主要的制定呢都是各种这个设备的文件、设备的规范或者是应用的规范。那么都是在这个小组里进行。如果您有 您在使用过程中，如果有关于对这个401规范啊，或者是任何其他规范有一些问题，或者是有一些反馈的话呢，您可以发邮件给我们。然后如果这个问题我们是会在小组中讨论的，如果通过了的话呢，会再发表到下一版的新版的文件中。Next page。我们呢 CiA 有若干的时长小组，包含这个CANopen FD，还有电梯，然后呢会在这个展会啊，或者是我们的出版物上呢做一些介绍和这个演讲。Next page。那 CiA 呢，它主要就是以这个我们的各种文件规范为核心，提供呢给这个设备生产商呢和系统设计人员呢，这个基础的这个规范这个信息，然后呢，您们呢可以参加，比如说我们的研讨会啊，或者是行业会议啊，或者是国际看会议，然后呢，也可以，您如果有新产品或者是新技术呢，也可以发表到我们这个技术杂志上。然后对自己的产品进行宣传，或者是我们在这个展会的时候也会有一些联合展台，但是现在呢，因为新冠呢，这个就目前都停滞了。OK，next page。我们呢有这个月刊的这个订阅邮件，像这个信息邮件呢，它主要就是各种基于 CiA 的信息啊，和当有新文件发表的时候啊，都会在这里面呢通知大家。另外呢，我们也在这个各种的社交媒体上可以找到我们。然后呢，咱们在中国呢就是用微信。那请您呢可以，如果同事啊感兴趣的话呢，可以让他们扫一下我们的二维码加我们。OK，next page。那么这个国际看会议呢，主要就是我们组织的这么一个会议呢，参加的都是各个公司的技术人员，主要讲解呢就是基于 CAN 的物理层或者是高层协议的一些新的技术和新的发展。这个本来呢是应该在去年举行的，但是呢因为这个新冠呢就没能成行，因为它是一个面对面的会议，现场会议。那么今年呢我们会把它已经变成了在线的形式，它是会在6月14号到17号之间来举行。如果那它现在变成在线的形式，其实如果咱们中国的朋友如果有兴趣的话呢，也可以来参加。如果您感兴趣的话呢，可以这个在我们这个网站上后面这个-ICC 上面来看这个有这个 program 的详细信息，然后呢也可以发邮件呢到我们的 secretary 来了解这个具体怎么报名。OK，next page。那么这就是简要的 CiA 会员呢有一些这个优势和一些可以得到的一些服务。主要的话呢，对于咱们设备开发人员呢，就是可以得到最新版的这个规范。因为新版的规范并不是所有的都是免费下载的，所以呢还是呢而且我们 CiA 呢是推荐，如果您是开发设备的话呢，还是最好用最新版的这个规范。因为它呢会就是说之前的老版呢，它可能里面比如说有一些错误啊，或者是然后在新版中都会得到更正，并且新版呢也会有的是增加了一些新的一些功能。Okay, next page. Okay, so then I hand over to Mr. Kaplun. 那我现在就把这个基础内容呢交给Kaplun 先生呢，他现在来给大家讲解。那么在每一章这个 PPT 后面呢，我会用中文呢稍微给大家做一个总结。Okay, Mr. Kaplun, you can start.
Thank you, Yao, for introduction. Then we can start with the purpose of our, one of the purposes, further purposes of our webinar today. Please bear in mind that it would take much longer to discuss, to explain all these small details. We just go an overview of what CANopen offers in regarding of development of CANopen I/O modules, and what could be your benefits. And you could see in details what we have done by now, what it is all about. In the first side, this webinar is addressed to the people who already know a thing or two about CANopen, so it will be easier to start with that. If not, you can attend our other webinars or even seminars where you have longer time explained how to handle CANopen, what are device profiles, and what is this all about, what CANautomation does to offer in this place. But we go specific, assuming you know a little bit about CANopen, we go straight to the first step when you decide to develop an I/O module with CANopen interface. Before I continue, I wasn't sure if this all information was done by now. You can ask your questions in the meantime if you find them, preferably over the chat. My colleague will wire to me, or you can ask even in your mother tongue, so it will be quite comfortable for you. Well, you see a nice picture here. They are typical I/O modules with whatever that might be. It could be some different interface, not only CANopen. For the CANopen interface, this means the specific CANopen data is provided in this device. And first step, you start with a specification. You find how to implement it according to what. Beside this one, you need, of course, the software. You need CAN hardware, CAN controller, CAN transceiver. Design your application hardware. When it comes to software, you also need CANopen protocol stack, CANopen application, and all of these things are already specified. Also, you would need a basic specification. CiA 301 is not listed here. But it is important to start with this because it has information about CANopen application layer and communication profile in general that you might use and implement some of the functions in your I/O module. So the I/O device specification is designed based on 301, but goes into specific, provides the I/O specific data interface. You will find this information, this specification in two parts at CANautomation. You can purchase it or become a member of ours, then you get it for free. You can have access even to the development version. But, well, anyways, we are sticking with the specification itself. It has two parts as of right now. They are valid, can be obtained right now from CANautomation. One specifies how to handle I/O modules in general. What is a CANopen interface? What application data, communication parameters you need there? This you find in part one. In part two, you will find specific information for the specific kind of I/O module, such as joysticks. Further applications, even what you would design yourself, are provided in 852 technical report. It's just an example of operating environment, including joysticks and several other functionalities having inside I/O modules. But you can design your own application based on 401. Then this is all specifications are designed by CANautomation with all our members, not with all our members, a special interest group. There are a couple of members who also develop such devices. They decide among themselves how to maintain, extend this specification with its functionality. Please bear in mind, I/O modules, generic I/O modules is the group and the specification is 401. If you want to do this, then you may contact us and ask questions straight about the specification, how to handle it. So now to the key message. Yao, please, can you do this shortly?
所以呢，这个 CiA 401呢，它是分成两个部分啊。它的这个第一部分呢，就是定义的通用的这个I/O模块的一个这个过程数据啊， 还有就是你这个接口具体的你这个 I/O 的每一个接口的数据是存在哪里，它是在这个第一部分来定义的。那么第二部分就是专门是这个操纵感的一个特殊的一个数据的它的一个定义。那么这个另外还有一个这个技术报告852，它这个应该是后面会更新的。目前呢，它是讲一个这个操作环境的一个子系统的一个定义。OK，next page。
So when you have already specification itself, that is, of course, a question I mentioned before. You need software, how to program it, and a software inside application software inside of your device. You need CANopen protocol stack and so on. Imagine the situation you have already a system with those devices. Then it would be look like that on this slide. You can find here in this way, CANopen networks are typically controlled by a main device which manages network specific tasks. It also starts devices, monitors how they operate. If there are some troubles, it can also turn down the network and so on. This is one is above on the top. This is a PLC or CNC, whatever it might be. And on the bottom of the picture, you see single devices with the pictures of this, like motor, I/O modules, encoder. They are typical possible network, CANopen network, but they are simple devices which are controlled by PLC and sent in CANopen way the data across CAN network. The important, interesting thing here is that CANopen device A and CANopen device C are both I/O modules, could be or could be. They could be also identical devices, not simply I/O modules, but digital inputs. But the interesting thing, they could be from different manufacturer. So you would ask how you can reach this point that devices from different manufacturers have suddenly operating in the same network. It should be an enormous configuration to bring them together. No, we have already handled that, and this is called device profiles. Device profiles provides a standardized interface for a certain class of devices, such as 401 devices, and simple, similar at CANopen. More of it, that devices could be even identical, thanks only to the device profile. So, Yao, please.
Okay. 那么这一张 PPT 呢，就是讲这个设备规范，它主要的目的呢，就是可以使这个设备间呢，它都是兼容的。那么它的一个主要目的就是使这个网络设计的话呢，就简化了，因为你这个同样的数据呢，都是存在一个同样的位置上，所以说呢，不用重新进行对系统进行编程和这个设计，那么大大简化了这个系统的这个网络的设计。OK。
So there was a typical network where you find the I/O modules, devices. They could be different, could be of the same kind, but most of it was defined by the device profile. So now we take a closer look. What makes a device profile like such as I/O module device 401 that unique and that specific that it could be also identical devices? And we see there are parameters. As I said, this is data interface across this 401 devices is the same. They could be distinguished only by the certain parameters, their Pdo mapping, as you can see from these pictures, from this slide. There is also important parameters that shall be there to make it happen. This is object 1000. This object specifies device type, such as 401. but it is mandatory for any CANopen devices. So if you find a device or you want to design a device, you know that you find the straight information in the object 1000. If you want to manage errors in a network and know how the device operates under certain conditions, what does it do in case of error, then object 1029 could be helpful. It is, but optional. Please bear in mind that CANopen is very flexible. Only few parameters, actually, few parameters and only few protocols are required to call the device CANopen and even to make it operate as a CANopen device. So, beside the PDO, you have application-specific parameters for 401. They are across all 401 devices the same. It differs only based on a device functionality. Device, digital input, analog input, output, joystick, whatever it might be. For each one, there are certain parameters in a very same parameter, CANopen parameter range. You have to pick the right parameters to create your device. But this one you will find in a specification 401.
那么这张PPT 呢，就是讲这个我们这个401文件包含的如下的这些定义，这些数据对象。那么它的这个 CANopen 的设备配置文件，它的另一个优势呢，就是说它是有这个可伸缩性的，不用就是说所有的这个数据对象啊，或者是这个功能都要支持，仅仅可以就是说。就是仅仅支持必须支持的一些功能，所以说呢，如果您需要的话可以支持，不需要的话呢，就仅仅支持您需要的功能，就是非常非常的灵活的。OK。
So then you learned about the device profiles, what is main interesting point, but we go in deep a little bit to make you more understand how exactly can you distinguish between the devices if this same parameter is across all 401 device? How can you distinguish this device between the kind? Where do you know that this is digital input and not analog output? So this one is in the side of the parameter 1000. The lower 15 bits indicate the number of specification that you know to which device profile does it belong. And the upper 16-bit provide for every device more or less information about its base and general functionality. As you can see, bits 16 to 19 provide information about currently generic kind of IO devices. If you design the device, you can read this, provide this information inside, and someone who designs the network of these devices could, with only one read try of this object, find out what is this 401 device is all about. What IO functionality does it have? And what additional functionality does it support? As you can see, there is also specific functionality available there. And you can see also that you could design not only digital inputs and outputs, but the very specific functionality using them, such as joysticks. And it is also possible to design output panels, such as displays, HMI, or whatever else uses inputs and outputs. Because there's nothing else, display and buttons are nothing else as inputs and outputs accordingly. What you have here interesting too is this bit M, which if indicating predefined Pdo mapping says we can have identical devices. But for your flexibility, you may also use your own Pdo mapping. For your specific, say, my I/O module, I want to have it very specific functionality. Maybe I use it in my network only. You can define device-specific mapping, and for that you set the bit M to different value as 1. So you see the object 1000 actually provides the information about the device and its capability. We said also about process data object in CANopen, by which mean you transmit, sorry, very little.
OK, yeah.那么这一章呢，主要就是讲这个对象呢1000这个设备类型的这个对象。那么你也看到这个如图所示呢，它可以定义。首先它一个规则呢，首先它提供一个信息，就是说我这个设备是执行的哪一个文件，那么就是在0到15的这个比特里面。那么还有其他的就是比如说这个是哪一种功能，或者是特殊功能，比如说操纵杆。那么主要就是提供一个这个信息。OK, next.
So we said beyond the data and parameters, we need also communication, process data communication. That is also then standardized in device profiles. And here you see the current Pdo distribution. This is called process data object, where you map your process data, such as input values, output values, whatever you need to send across the network to the device which collects and processes this information any further. In this device profile, we have standardized mapping. And for this one, we selected device number 1 with node ID, so-called identification of the device across the network. And based on it, you have Pdo communication and mapping parameter designed in there. As you know, as you may know, CANID is the communication setting of Pdo, and it is set to the node ID 1 in the devices. When you configure your devices, the number may be different, but by default, every device is supplied with it, with its default behavior, provide with default PDOs exactly this CANID, which means actually I can purchase these devices, connect to my network, and basically I don't need any much configuration with that if it is suffice my needs. Shortly about the mapping itself, you see the mapping is selected very optimized to put only necessary values inside. So for what I need for each type of the device, I can use only one single PDO. An example of digital inputs, there will be data which is coming inside. We see this in the next slides, how this I/O digital input is designed. Then you see that I fill this PDO with the digital input data, and I could put only up to 8 sets times 8 bits, 8 inputs. So maximum 64 inputs per one PDO for digital inputs. It's already much enough that if I need more, then it will be discussed in the next slides. In the next slides, when we come to the CANopen FD. But for now, for most of the devices, it would be sufficient to have 64 inputs. If in case of digital inputs, it can be, of course, extended by the manufacturer-specific PDOs. But by default, every 401 digital input device from different manufacturers delivers by default exactly this TPDO. The same applies to the other kinds of I/O modules, output, analog values, and so on. Analog inputs and outputs, as you can see, we actually filled with only 4 PDOs. We could cover basic implementation of the device with all 4 kinds of I/O modules on it. Yao?
OK，那么这张 PPT 呢，就是主要是讲的，就是如果是您使用这个默认的T 或者是 R Pdo 的话呢，它这个设备呢，在网络中呢，其实是完全可以互换的，它是兼容的。那么呢，它是提供这个默认的 Pdo 呢，它是提供64个输入输出。并且呢，最多是有这个4对默认的Pdo， 那么它其实基本上可以满足这个现在的一个使用的需求。OK, next.
So then how the Pdos are sent actually? Here I have some relatively small example how it works in a real network. All of those devices are actually I/O modules. Most of the devices are very simple devices. For example, devices marked in yellow are just digital inputs, nothing else. They just send and they support, for example, in this example, only up to 64 bits, 64 inputs. They provide this value across the network, and there should be also another device who could receive this data. And this device cannot be any other. It couldn't be device D, for example, because despite the fact that it has RPDO1, because TPDO and RPDO are meant to be configuration of the PDO, which is truly submitted across the network. But in the device, this PDO is called transmit PDO or receive PDO, depending on its purpose. If it is called transmit PDO, then this device sends this PDO. If it's called receive PDO, the device receives this. So if you look deep into 401, you will find out that TPDO1 is for digital inputs and receive PDO1s is for digital outputs. So they are not compatible, they are not receiving the same information. They're completely different. To make it work, I need actually device such as device H, which, for example, can receive TPDO1. And you see this in device H, RPDO5, this additional PDO I defined, exactly to receive the TPDO1 from the other devices. On a bus, again, I see only PDO, but in my device, I configure it for reception or transmission. Device H configures TPDO1 for the reception, and thus it is called in this device RPDO5. But this content is identical. So I can process this data, such as there could be a button click, and my device H could be indicating this information on display that a kind of button was pressed. This is just to information how the network and process data coming across the network. The device who is having TPDO is a producing device, and a device who receives PDO is a consuming device in this case. This fits very well into CAN communication model, producer-consumer, only one sends, but the other could receive this data. On this one is also designed the PDO communication. So then a couple next slides, I would like to introduce you to the block diagram of the digital inputs and digital outputs to make you clear how these things are work internally, what are the single parts of it, and where do you find the process value and when it starts to transmit it. So the simple example in there, you see on the left side, this is digital 401 digital input typical diagram for that. On the left side, in the left upper corner, I see single digital input. It goes the information into device through the filtering and changing polarity if it's necessary, and goes stored in an object dictionary as a process value after these processes. And it can be transmitted, mapped into Pdo in the protocol stack. But as we can see, it cannot be transmitted simply like this. It requires, as every operation in a network, it requires certain trigger condition. A very effective way of communication is actually event-triggered one. You can do also synchronous, whatever you need, could be done also with I/O modules. But the ideal way to do so is doing this in event by triggering through an event, whatever it might be. For digital inputs, there are certain events defined, standardized events, which you could use. And this means every device is using either one or the other trigger condition. And this makes them very compatible, especially in regard of application itself. So the trigger condition, there are 3 trigger conditions, as you see, but even more of those. You see this change of both edges, rising and falling edge. This is the first picture in black under trigger condition. The second one is falling edge. And third one is on rising edge. They are trigger conditions based on the input signal, if this currently was on a rising, then in a comparator, we compare which one is eligible to trigger, which trigger, or maybe one or many trigger are triggered at the same time. And thus, in a data transmission trigger block, you decide either the prepared transmission in Pdo mapping shall be also transmitted over the CAN. Generally simple simple way how to do so. The trigger conditions are standardized. You can use any of those, and this limits from one point of view, but on the other hand produces compatible devices on the network. Another example would be also useful to say about analog values. There is slightly different scheme how to do so. Just to go into technical details, we have an analog input. It shall be gone through the analog digital converter. Then signal shall be conditioning, scaled, downsized. Then it lands also in an object dictionary, but still cannot be submitted the same way as the digital input, because you might find handy to trigger it on under certain conditions. Otherwise, the devices would be triggered with whatever it might be, but they will be all incompatible or maybe having only one trigger condition, whatever. So we designed several trigger conditions in there. So you have to choose between them. And their trigger conditions are chosen wisely to cover all possible scenarios that could be in there. So the value can be bigger and higher than limit value, whatever it might be. And third one, there's actually many conditions inside this. This is infinitesimally small change of the value could be also a trigger condition which triggers our transmission. But it could be negative, positive, whatever it might be. So totally it makes actually 5 to 6 standardized trigger conditions. And they come into block trigger. And once everything's set, the trigger condition is decided, the data transmission occurs and the analog input goes through the network and to its acceptance device, which receives it. So then Yao, please.
那么这2章呢 ，PPT 主要就是主要讲了一下这个具体的数字和模拟输入的一个示例。那么它主要讲的内容就是说，这个 trigger condition 这个触动的条件呢是定义在这个文件中的，所以说呢，它完全是可以就是说来自己就是完全可以直接来使用的。OK。
Well, so you learned about a little bit about 401, about CANopen I/O modules, how we have a structured what is inside life of these devices. Then when you have possibly designed the device or receive it in a hand, mostly if you design it by yourself, then you would like to verify if it is working correctly. Not only from the point of view of 401, but from CANopen point of view. Can it be operating CANopen networks? So for this reason, we offer testing. We offer test tool. We do also conformance testing for CANopen devices in general, and could approve all device profiles, any device profiles. It makes sense. Additionally, you could also verify if the device could also operate in the same network at the very limited capabilities, though that is interoperability test. And we do also offer PlugFest, where not only we test in one-to-one session the device, but several manufacturers of the devices can come together. We test it in one typical CANopen network. So the reason for that, to make the device not only compatible, but verify their compatibility if it's true and it is working in the network. So we learned about 401 brief. In generic, about generic input outputs, it is also possible to design in there. But there are also some specific things that you could do. You just take 401 specification, and only thing you need is to map the parameters of your device in a specific way, and you could design any very specific devices, not only input and output, but joysticks, HMIs, operator environment with multiple joysticks, buttons, and indicators, maybe plenty of displays. That is, everything can be done with 401. However, you need some parameters to define the specific parameter, but in this case, you utilize the generic 401 parameters for the purpose of specific functionality of the joysticks. So for example, you have some buttons for a joystick, and you have some values to recognize, to see where the joystick moves itself, and provide this information to approve if the joystick moves in correct position and set the correct settings in there. For that, you can see the second TPDO can transmit in 2 bytes, can transmit in 2 bits the button state, and in a second, 3 analog values across each axis of the joystick if it supports, for example, 3D positioning, such as along 3 axes, X, Y, and Z. If you have to indicate, to show what is going on there, for example, across each of the axes, if the value are indicated, you could map this information into a receive video. And so you became your joystick. Such a way you could design plenty of the devices which in background have just the things with input and output of whatever kind. So, thank you, please, Yao.
所以说呢，就是401也支持这个特殊的一些应用，比如说这个操纵杆。那么呢，它其实用的这个数据呢，都是在这个-1里面定义的呢。但是呢，就是说-2它就是这个操纵杆的文件，它就是定义了如何用在-1里面定义的那些数据，然后呢，哪些是操纵杆需要的，并且呢，在操纵杆的这个接口里面它是存在哪个位置的，那么这个就主要是这个-2操纵杆文件的一个提供的一个信息。Okay, next.
Thank you. So now we take a look into very close future, CANopen FT and CANFT and CANopen FT already applied to I/O modules. So the reason for that, you have a classic CAN, it supports only up to 8 bytes of data and transmits at speed maximum 1 megabit. However, if you want to transmit more data, there was no standard for that for the CAN. So the Robert Bosch developed one on behalf of automotive, but we in industrial automation could use this advantage for us. This one is called new CAN protocol, CANFT. It allows not only up to 64 data bytes. You see this in a second frame. But also you can switch the bitrate, and you can switch the bitrate, especially in data transmission, to transmit my data quickly than usually. So.
所以呢 CANFT 呢，它这个主要和 CAN 这个经典 CAN 它的数据帧的格式基本上是一样的。那就是说它提升的就主要是这个数据场的长度呢，从这个8 byte 提高到了64 byte。Okay, next.
Based on this amazing capability, it opens various possibilities for not only for every device or application profiles that can open, such as 401, but in general, we have adopted our CANopen specification to this CANFT, and now we have 2 specifications allowing to pursue 2 different technologies, and we could optimize our previous one, CANopen, using CANFT, and it is called CANopen FT. With this one, there is universal STO protocols, which replace in CANopen FT the STO, and it offers some key opportunities and possibilities. To one point, to list them all will be not enough time to have in here, but I'll just tell about few of those. In the first place, with a classical CANopen, you have to design a straight communication pair, client and server. You have to establish it, you have to configure this. These things are no longer necessary in CANopen FT with using universal STO. You use the same node ID, the sender uses the same node IDs itself, and doesn't need to configure itself onto every device it would like to ask the information about. It's just send the information. All the details are provided in the frame itself, but we come to this in the next slides. So this is key important feature. There are various possibilities how to transmit the message itself. It can be also broadcasted similar to Pdo. This is not possible in classic CANopen. But again, it is your choice which one to take, either CANopen one or CANopen FD. All have their advantages. And you have now this big choice. Besides this, Universal STO offers kind of parallel access to the very same device. So you could establish to access several parameters with three distinguished USTO messages onto the very same device. You could even send the data over USTO across multiple networks using transparent gateway, but we'll talk about this later. So the USTO offers some interesting capabilities. How does it fit into? This is just a couple small examples before we're going to the variation of CANopen FD 43401. So the whole configuration is actually done not in the parameters themselves, as it was before, as it is actually in classical CANopen, which still remains at large, but it is done in a message itself. Imagine it has 64 bytes, and a couple of bytes I could spare for control data, such as command specifier, the address where this message goes to, the session ID to distinguish between several messages to the same device, and then the data itself. And this one can be sent in broadcast as well. You can find these details in the specification 1301 in details. And also you see the return message, the confirmation message is only 6 bytes long, which is much smaller than STO. And this means USTO is actually has a flexible fields, transmission fields at all. So this is an additional advantage in this.
所以呢，这个401的这个新发展呢，就是说将它映射到这个CANopen FD 上呢，这个基于这个 CANFD 的一个新的这个CANopen通讯协议。那么这个通用SDO， 也就是 USDO， 就是它的一个新的功能。那么呢，它的比 SDO 增加的点呢，就是说它有了这个可以寻址的这个功能，就是您看到的这个列表和这个前面的这个地址，这个目的地的地址。那么这个具体的并且呢，它比这个 SDO 增加了这个广播和多播的功能，这个以前在 SDO 是没有的。那么具体的呢，您可以在这个1301的这个 CANopen FD 的文件中呢来找到。Okay, next.
So briefly on the remote USTO, this is what I said previously. You could transmit the message from one device across the transparent gateway to the other CANopen network, effectively allowing to cross networks. In one CANopen network, you can have only 127 devices, you can access them. But what about other networks? You have to design a complex scheme where you have to reassign the data, CAN IDs within this gateway to reassign for another network. This one doesn't require this. Using this remote USTO, as you can see, I have here destination and source network ID. This is new thing introduced with USTO, allowing this to communicate across networks.
所以另一个USDO 的新功能呢，就是可以访问其他的网络。那么这个在经典 CANopen 里面也是没有的，就是通过这个网关来通过寻址功能来访问其他的网络。Okay, next.
Yes, we learned about USDO was important in this in CANopen FD because we have also a version of 401 for CANopen FD as well. We don't have it yet, but we are very close. We are in development stage now, and we're very close for release. As you can see, the name of the specification is the very same, but now it has two technologies inside. So effectively, this new version replaces also the older CANopen one although CANopen mapping remains the same. The only difference between them is that additionally, CANopen FD Pdo mapping is added. To make this clear and understandable, if you design this, we separated functionality-related parts into 3 distinct parts. Part B, all application parameters. And in part C for CANopen, part F for CANopen FD, you have only parameters for Pdo communication and Pdo mapping itself, because they are only the different, and they also distinguish between the access for parameters, because in CANopen FD there is always USTO, and in CANopen it is STO. They are not compatible, STO and USTO. That is why you have to choose wisely which one to integrate. And this specification is still maintained with the very same working group. Yao?
所以呢，这个新发表的新版的401以后将会呢代替老版的401。那么，并且它的特点就是它会将分成3部分，这个 B 和 C 和 F。那么 B 呢就是基本的参数的定义 ，C 呢就是这个 PDO 映射的定义，那么 FD 呢就是这个新的这个基于 FD 的 PDO 的一个映射的定义。Okay, next.
So, but we still wanted to maintain the backwards compatibility. So if you have older devices, for example, CANopen devices in the same network operating with some kind of bridge, which still allows me to operate the same devices. But we have one stage which collects the data from all devices and would like to configure both networks. It is still possible because the very key parameters, such as object 1000, remain structurally the same. So as you see, we have not changed I/O functionality, bit field, and you recognize the same specific functionality for joysticks. And the device profile number is the same, it's okay, it's understandable. And it's also the same bit M, allowing you to indicate Pdo mapping kind, either this is default or manufacturer specific. So not only this one is compatible, but there are some additions. Based on this remote USTO, you may, of course, consider to design your I/O module not only as I/O module, but you may design a gateway with some I/O functionality, and you would like to have some kind of cross-network communication between the networks. To make it possible, there are objects available in specification 1301, object 10,040, port network allocation, and routing table, allowing me to know which devices goes to which network, and this information is stored by the default in my gateway. So I don't need to have any manufacturer-specific parameters for this. They are all already standardized parameters available for this. What about Pdo mapping? We have, as I said, CANopen mapping, CANopen I/O remains here, also with a new specification. This is also split it into parts. In a part C, you have exactly the same Pdo mapping for the process data you had for I/O modules as before. So it is backwards compatible. What about CANopen FD mapping? So we said we would like to utilize the full extent of data capability. So you could put 8 times more digital inputs, analog inputs in there. So, but for this reason, we don't need many PDOs for very place-hungry analog inputs or outputs, but we could use only 2 of those. We have a corresponding pairs for each kind of devices, TPDO for inputs, sorry, and RPDOs for outputs. As you can see, you can find them here. And the mapping is extended.
那么这个在这个使用这个基于CANopen FD 的401呢，那么它也是和这个经典CANopen的这个401是兼容的。OK。
So, and also for CANopen FD, especially for 401 devices, either they are CANopen devices. For CANopen variation, we have already discussed this about test, interoperability test, and so on. And if you decide that you would like to have designed CANopen FD device, then we have also opportunity now for testing this for conformance to the CANopen FD protocol specification. We don't test the devices themselves according to 401, but rather to conform with 1301 in this case, to become conform to the base CANopen FD specification. This is the main reason. And this is mandatory today, nowadays. And we have not the test tool yet, but we have already testing procedure. This means you could send us your device and we test it. And you receive the confirmation if the device is CANopen FD conform. Well, that is short, a brief overview of what we have learned today. 401 is soon become additionally with CANopen FD equipped. You have two distinct part of mapping where you could distinguish between kind of specification, either is CANopen device or CANopen FD, all under one and the same specification number 401. Additionally, you have the standardized profile, device profile, which you could use and could be compatible to the similar devices from the other manufacturers. You could verify the device by sending to us. You could participate in a Plugfest to check your device in a real network. And if you would like, beside the development, also bring your requirements to 401, then become CAN Automation member. And you can do this together in this special interest group. Well, this is all from my side.
Okay. Thank you, Mr. Kaplun. 好，那么今天呢讲解就到此结束。那么您如果有问题的话呢，可以现在提到 chat 里面。我们现在还有一点时间可以回答提问。如果没有的话呢，也可以如果后面有问题的话，也可以发邮件给我们，随时可以回答您的邮件。那么现在您看到就是我们其实本来都是有在全世界参加展会的，但是现在因为这个新冠呢也参加不了了。如果可行的话呢，我们2022年呢还会去参加上海宝马，所以以后再看。Okay, next page. 后续的呢，我们也有一些其他的直播的课程，包含英语的。其实英语的你也可以参加。英语的话呢，我就不会在这个微信公众号上发了，您可以到我们的网站上来报名。然后还有汉语的，然后呢还有俄语的，这个可能咱们就不需要了。Okay, next page. OK, 那么今天呢就到此结束呢。我们的这个微信公众号呢升级了，所以呢希望您可以手动关注一下这个新版的公众号。OK, 如果我没有看到一些问题的话呢，那么今天就到此结束了。感谢您的参与。然后呢，这个哔哩哔哩上面会上传今天的这个视频，我会在公众号上发。OK, 大家那就谢谢，再见。
Then we will thank you very much for today's participation. Welcome to see you in the next ones.
Okay, bye-bye.